Yeah, so we have some participants, but they are a little bit shy. I don't know.
That's okay.
So,
Okay, do you want me to start? You want to introduce
yeah,
yourself
so
again? And
good afternoon, everybody. Now we welcome Professor Tanega, one of the world famous professor in our planet, and he will introduce very interesting subjects. We are waiting for that's mathematical philosophy of law and finance. And one of the things is this idea is very new and originate. So the original thing is very important. So here's your show.
okay, thank you, James, Professor James. Hmm. This topic is so general and in some sense so abstract that if you are a lawyer or if you are studying law, you might wonder, what the hell is this? It seems so abstract, but I think it's an important problem that I'm going to talk about. And the problem, actually, if we think of it from purely a legal perspective, it's really about the power of law. The power of law. What does law give us is one question, but then another, probably a much more important question is, what can law do for us, right? And if you're a practicing lawyer, I know when I was in law school, one of the first lectures I got was from a Professor Fink, Fink, from Yale University. And he came in dripping in sweat, in tennis shorts, and a small beard. But he is a very, very famous academic and writer because he was the editor, the main editor for the second edition of the Federal Rules of Civil Procedure. It's like 30 volumes. It's huge. And he was the editor. So one of the things he told us, and I think this is an important lesson for all lawyers, he said, if you're a lawyer, it's not that you can just win a case. If you're a lawyer, you can stop a bad person from doing more bad, more evil, more crimes. And if you're a lawyer, you can stop a company, a big company, small company, big company, doesn't matter. And if you're a lawyer, you can stop the state or the city and then the state. And then he finished it off like this. He said, and if you're a lawyer, a single lawyer in the United States, you can stop the entire United States. And I thought, really? I was a very young guy. I was very innocent. I think I still am, but I mean, not a young guy, but very innocent. And I thought, wow, that's an amazing power. One lawyer that can stop the entire United States. Now, if you think about that for a second, you might think, okay, that sounds like an exaggeration. But after the many years of practicing law and being a professor in law and finance, I know that's only partly true. What do I mean by that? Is that if you actually look at the way the law works from a broad historical perspective, and when I say broad, I'm really talking about in my experience, my teaching experience, my scholarship goes back to the Roman law and then through the 2000 years plus history. And I have noticed that the law, as it is conceived and as it is practiced, can not only stop or encourage action in one country, but it can impact and influence and greatly move societies in many societies. I mean, many people, many leaders in many societies. Law is fundamental to the way we actually work together in what I call a collective intelligence. And this is an important idea. And because it's not discussed too much, or hardly ever, but in the law, I look to other fields for assistance. I look for other fields talking about this idea. How is it that humans are organized? And recently, I worked on a paper with a colleague from Saudi Arabia, and happily, this paper will be published in the University of Pennsylvania Asian Law Review, which University Law School, University of Pennsylvania, is ranked number 4 in the United States. And coincidentally, that's the same ranking as Harvard University. The paper is titled Saudi Environmental Law. So this is the beginning, you might say, an introduction to the idea in this lecture. Hold on. Let me just move this screen slightly. Anyway, in that paper, I mentioned a great scholar who's, I think, is still alive. His name is Lawrence Tribe, Tribe. He's at Harvard now. But he wrote a very famous paper, I think in 1974. It was on plastic trees. Kind of funny title. But it was about environmental law. And he set out a couple principles which we will use in this lecture, and hopefully you might use in your own professional, personal life. He said that environmental law is not just about nature, about how we deal or interact with the environment and how we might control ourselves in relation to the environment. No, environmental law gives us a way of envisioning future civilizations. And I thought, wow, that's a huge idea. And it was not just about envisioning future civilizations. I think he used the word guardrail. Just as you are on a train track and you have guardrails, so your train goes in that direction where the rails are. So he conceived of this notion that environmental law actually gives us not just a sense of purpose to protect the environment, but literally gives birth to the law that will become the guardrails to civilization. Wow, what an amazing idea. So anyway, that's one of Tribe's idea in that article, and I would highly recommend you look at it, because it not only pitches a future vision of what society can be with the appropriate laws, but he also gives us a sense of the past. So a large portion of that article is devoted to what I would consider 19th century socioeconomic thought. And when we look at it from that sense, there's utilitarianism, there's this type of rationalism in the 19th century. And then this notion, I dare say, that's picked up from the ancients and through the Middle Ages of what a good person should be. What is the consciousness of a good person? And that good person has a lot of, what can I say, has a lot of interactions with other people in society, and through those interactions creates the good. Okay, I won't bother you with the detail of the past. I want to present a slightly different idea, but with the same purpose as Tribe, to try to describe a future state of humanity, and not just humanity, but what we would consider projects that, for lack of a better word, are multi-generational, extremely expansive, out to outer space, and not just outer space, but also inner space. And I will talk about a few physicists who moved in that direction. So let me just jump into, let's say, the center core of the lecture. And it begins, and remember the lecture's title is The Mathematical Philosophy of Law and Finance, which is, I think, is an awesome title. And it's awesome because nobody understands what those words mean altogether. There are 4 subject matters, and I think they all interact: mathematics, philosophy, law, and finance. Wow, that seems crazy. Well, I'm lucky. I'm blessed because I have friends out there in Facebook land, and one of them, who's a mathematician, told me, Joe, your interest in mathematics needs to be deepened. He was very, very polite. So he recommended that I look at a book by an author, a great mathematician actually in the 20th century, named Maclean. And he wrote a book, and he referred me exactly to this book in Mathematics Form and Function, MFF, 1986, I think. So even if you don't know any mathematics at all, or if you're curious, it's slightly technical, but it's not too bad. I mean, if anybody wants to do a reading group on just that book, and you're not a mathematician, I'd be very happy to entertain a reading group on that book. Because whilst I think, and a lot of mathematicians think that book is great, it's never used. It's never used in universities. Why? Because it's too wide. It covers huge territory of mathematics. And the image there is that mathematics is like a beautiful pearl necklace, or like a beautiful set of archipelagan islands in the Pacific. They stretch across a vast terrain, and it's not clear how each subject, literally, each specialized subject in mathematics is related to something else. But people who understand math know that they are related somehow, and that there are these weird connections between the subject matter. That's beautiful. So that's the image. So the great Maclean, in a very simple table, like remarkably simple table 3, I think something like on page 35, or I think there it says there. Yeah, the table 1, sorry, table 1.1 on page 33, he sets up this, lack of a better word, it's sort of like a spreadsheet. And it's an attempt to explain how mathematicians think, and how mathematicians create, and how mathematicians talk. Language. This is really important. Now, I always say to people, okay, language is very interesting because we think we're doing something when we talk, besides breathing. We're communicating. But it's interesting when you think about what language does. Language is just vibration in the air. We create these vibrations with this biological instrument. And these vibrations go through the air, and they hit our ears. They affect our body. And then we translate them, quote unquote, into something that we understand or think we understand. This is incredible. Just think about that mechanism. And language, like to put it in a slogan, bends reality. So we use language, but the language that we use, literally, physically, isn't about everything in the universe. In fact, what we are using is a tiny, tiny, tiny fraction of what could possibly happen in the universe. And yet, we're able to do incredible things with our language. We can organize huge organizations. Think about the late 19th century. The law in the late 19th century was what? Well, we had the first industrial era. And what did we have in the great industrial era, that first industrial era? We had the creation of great wealth and huge organizations. Hundreds of thousands of people had to be organized. And then what? Well, the owners died. Then what? Well, you had to have legal structures which could pass ownership, control, and management. We had literally the vivification, the rendering of corporate law and finance, by the way. So what we had as law enabled very large collections of beings to be organized through time, intergenerationally. Now, if you've accumulated any wealth at all, you might be concerned, say, to pass that wealth to your family, your sons, daughters, wife, whatever, grandchildren. I mean, I'm 70 years old now. I have 4 grown-up children. And recently we've got 2 more grandchildren. So now I have 3 grandchildren. So you get this accumulation, these beings kind of populating the planet. And if you have any property at all, so we say in the law, and you're concerned about how that property might pass, well, you specify in a will or a trust on how to transfer that ownership to the next generation. Well, this transfer over to the next generation, if you generalize that idea, is an amazing concept. It's beyond you. When you're dead, something still happens. And if you were in the previous lecture, you know that that's actually a very good example of the dual correlative of Hoffeld called power versus liability. Power was created in the form of a will or a trust, and the liability, your beneficiaries in the will or the trust, they are the ones who are liable to receive the benefits. Anyway, reference to the previous lecture. Let's dig into this amazing table. I've changed the table slightly to add 2 more columns on the right. But the original table are the first 3 columns. So MacLean is trying to explain how mathematical language works. He stated that you might think that what humans do is that they observe activities. Let's call the first call, it says human activities, and this could be anything. It could be looking at the sun, it could be sunbathing, it could be going to the grocery shop, it could be anything at all. Those are human activities. And so some general human activities, such as collecting. And then he says ideas. So this is like a 1-word or a couple-word description of what that human activity is. So in sum, if you have a human activity that you actually observe, people are collecting tomatoes, they're collecting their check, they're collecting, I don't know, airplanes. It doesn't matter what they're collecting. And the idea is collection. Then he says that might be translated into a mathematical formulation. So how do in other words, what is the mathematical language? What's the vocab for the mathematician with regards to collecting and collection? And if you know a little bit about maths, it's pretty obvious. It's called the set of elements. I'm not going to pain you with the definition of a set, but let me see. Okay, it could get very technical suddenly. Let's look at the 3rd one. It says comparing. So we do this naturally every day. We compare, I don't know, how big something is to how small that other thing is. We might compare the beauty of this person to that person, and so on. But when we compare, the idea is enumeration. That is, we're thinking about these different elements. These different elements, different things, and we're giving them some kind of value. Well, the abstract form, or the language used in mathematics, and I'm not going to pain you again with the definition, but there is a specific word for that activity. It's called bijection. And the things that we're enumerating, each of these things in mathematical language is called a cardinal number. All right. We could go on, and the list goes on and on to give many examples, but that's sufficient. What I did, excuse me, this is not even a contribution. I just consider it an extension of the idea. I took MacLean's table and I extended it into legal language and what I call legal financial language or formulations. So, for example, collection, legal formulation, just sort of arbitrary out of a law professor's head. Well, those sound like legal entities, like corporations, and there are many others. How about the legal financial formulation? Well, if you know something about finance, accounting, anything in that area, well, you might think immediately about what? Assets and the ownership thereof, and so on and so forth. For comparing, look down at the third line. In the law, we compare, enumerate the bijection cardinal number on maths. But in the law, we might think of it as contracts, consideration, maybe even a word that we use in litigation and in decision and judge decision making, stare decisis. So that might be the legal formulation. And then finally, a legal financial formulation for the same idea of comparing, where if you know something about finance, again, you're thinking about risk and return. You're thinking about valuation. And obviously, you're comparing assets to liabilities. You think about a balance sheet. See, so these ideas are quite general and not only general, but generative. They give you a chance to analogize into your own discipline. Can you turn the slide, James? Next slide. I think there's a number 2. Was that? Oh, no. Go back. Go back. Go back. All right, well, let's just go to this slide. It's okay. We don't need to use 2. It's about the same stuff. So when we think about the first column, the human activities, I write here, and this is something that it was not in his table, but I just kind of put it in there. So concerned about environmental problems, social problems, carbonization, plastics, pollution, global warming. Okay, those things are observable human activities. So what are these ideas? Well, they're in the political and ethical realm, right? I mean, each of these things are not just technical scientific terms. When politicians use these terms, they're really trying to get votes, or they're trying to scare the hell out of you, or they're trying to move you. These words have a political and social meaning. Dare say in the environmental realm, it's gotten to the point where every nation state on the planet is thinking about reducing carbon emissions. And because I've been doing that kind of work for over 30 years, they really don't know what they're talking about scientifically. It's amazing what people are saying to me. I mean, just saying out loud, I just think, wow, that's mad. They don't even know what they're saying scientifically. But socially and politically, they're either trying to gain votes or destroy the other side. The mathematical formulation. Well, look at this. This is really quite a high level. the idea, when we're talking about such big structures and how they operate, we're in the mathematical realm of network theory and complexity theories. Now, for many of us who are not systems analysts, or let's call them management theorists, same kind of level, these words are not very significant. But so let me just kind of paint a picture for you to give you a clue. When you're at the top of an organization, like a huge organization with 10,000 employees, it's not possible for you to know what's going on at an individual, qua individual level. I remember I was actually a consultant, an environmental consultant for a little bit. The area was so new, even though I knew so little, I was thought of as an expert. I thought, this is crazy. And I was a consultant to the Royal Mail, a gigantic organization here in the UK, one of the largest organizations in the UK. And I was their consultant. And that's mad. But anyway, on one of my consulting gigs with the Royal Mail, I identified an area at a very large station which needed to be looked at, because what was reported is that every spring, 6 to 9 people would go to hospital. I said, what? Why? They said, I don't know, with breathing problems. And I said, every spring? I said, yeah, every spring. I said, that sounds like an environmental problem. Let's look. So with my own eyes, I was at the top of this building looking down at the site, and I said, what's that? I pointed down at the ground, and they said, what are you looking at? I said, that square and the cement. What's that? And they said, oh, funny, you should say. This is where we buried blah, blah, blah equipment. And I said, what? Anyway, this equipment is very, very much related to emissions. Okay, it's basically a power plant, and they had buried it. And I said, have you measured and monitored that? And said, no. I said, don't you think you should? Because you get people are sick every spring. Okay, this is just plain common sense on my part, right? It's not an environmental scientist talking. It's just like common sense. So I then talked to the head of that site. He had 10,000 employees, literally. And I told him orally, like, hey, you should get this checked out. I mean, seriously, it's so obvious. Something's there. He says, yeah, don't worry. And it was like, I don't get it. Like, you should just do it. Why are you fobbing me off? Why are you delaying? Like this? Finally, I was very strident. I said, look, in a letter, I said, look, if you do not do anything at all, I need to go public on this, because I feel it's my moral responsibility to make sure people don't get injured when it's obvious that something is going wrong. So please, will you do something? And he called me in for a meeting. And this is interesting, because this is how I think, however large the system is, however big the network is, however complex our civilization is, it depends on individual decisions. And sometimes those decisions that are really hard to make are at the top level, called the management decisions. And this is part of this I call management science of the collective intelligence. We need to think strategically and operationally about these huge superstructures that are intergenerational. Anyway, coming back to the story. So he called me into his office. This is the top guy, the CEO. And he said, Joe, this is so interesting. He's so wise. He goes, Joe, do you know how many employees I have? I go, I don't know exactly, but I know it's over 10,000. He goes, yes. Do you know how many die every day? And I was kind of shocked by the question. I was just like stunned by the question because I didn't know where he was going. He says, every day, 5 to 10 people die in my organization. Think about a biological, huge creature. And we are cells in that structure. No, and if it's really huge, of course, there are people who die and there are people who are born. Think about intergenerational systems, how big those are. And then the kinds of decisions that we have to make. And what are the legal structures that we would undertake in order to make sure those organizations are operating fairly to human beings? And that's exactly the point of that meeting. I didn't think it was fair for this huge organization to ignore environmental problems. And this guy was saying, I have a sense of priorities. Things need to be done in a certain order, or it can get much worse. Amazing. I learned a lot from that guy. I realized that no matter what my concerns were about the health of individuals, there may be a lot of concerns on his mind that were to protect many more. And so it's a matter of priority. So network complexity theory, then think about that type of ownership over a very broad spectrum of time, you might say, in the legal sense. I put up some words here: taxation, patents, securitization, something that I wrote books on. I won't go into here, but it's a type of financial instrument. And then in the very right, the legal financial formulation. And I say, interestingly, socio-sustainable derivatives, environmental credit rating, blockchain sustainable government credits, and asset-backed securities relating to the environment. Okay, so that sounds like, wow, that's airy-fairy stuff. But I assure you, when I wrote this, nobody was talking about blockchain. Nobody. So this was written at a time when I was just thinking, well, what could happen with the collective intelligence? What could happen at the broadest scale of humanity? Do we need to think like that as lawyers? I dare say that if you are in the law, you're doing it anyway. The stuff that you're doing every day are, like what Tribe said, you are creating literally the guardrails of civilization. That's what you're doing. Yeah, that train is on, it's going and going, and you're making the guardrails so that train can keep on going. All right, next slide. James, are you there? Did you fall asleep? Anyway, this is an abstraction of that same table. So bear with me. It's a little bit abstract, but I'll try to explain what this diagram means. And it might be helpful if you think about this a bit and you're thinking collective intelligence over many generations, or intergenerationally at least. Where might we define the problems, and where, listen to the word, where, not how, where might we find solutions? It's a strange question, okay? It's not the kind of question you normally ask at the legislative level. I mean, I used to be a deputy attorney general for the state of Hawaii, right? I was a really young guy. I was like 24 years old, and there were only 2 in-house counsel for this huge department of social services and housing. I think it's like $250 million a year. And as I look back at that time, and as a little ant in a huge machine, I thought, wait, like, what? What are we doing here? And I started to realize that any tiny thing that we did, anything we touched, anything we said, any action at all, had huge repercussions in that organization. A tiny decision could be tens of millions of dollars of taxpayers' money. And there was one judge who made this awful decision. He thought he was God, basically. And he said that in any filing by the state, that's us, the deputy attorney generals, any filing at all in court must have a certain notice attached to it on welfare rights. So I think I was like the third or fourth lawyer in a generation of lawyers fighting this this august judge. So in my first case in front of the court, the federal district court in Hawaii, I was a young guy. I was like 40 pounds lighter. I looked like James. I was so smart and, dapper. I came into the court and the judge was so angry. He just like